Hello everyone, this is TSS Zindabad and today we are going to discuss the daily challenge of Leetcode, which is unique number of occurrences. Let's jump into the problem statement. Given an array of integers ARR, return true if the number of occurrences of each value in the array is unique, else return a false. Okay, so let's understand what the problem statement says. It says that if I've been given something like this of an array, I need to tell that the occurrence of each value is unique or not. So when I talk about such a problem, I understand that here the first thing that I need to do is I need to know the occurrence, the number of occurrence, the number of occurrence for each value which is present in my array, right? For example, how many time is 1 coming, how many time is 2 coming, 3 coming, and if there are furthermore elements, how many times are they occurring throughout the array. After finding this occurrence, right, I need to store it somewhere, right? And then I need to work over this data structure in which the number of occurrences for each value of the array is stored and figure out if it is unique or not. Now, by unique, I mean that no two values should be same. So that means if, let us assume here using this example, I can see that 1 is occurring 3 times, 2 is occurring 2 times, 3 is occurring 1 time. So this is the number, or we can say this is the value, right? And this is the frequency. So I see all these frequencies are different. We do not have two here, right? If we had two here, we had two clashing frequencies which are same, so then we would have returned a false. But as we can see that in this case, we have a 1, right? And hence these all three are unique. So we can simply return a true. So this is the problem statement. Now let's talk about the approach. So guys, if you have worked with something like an unordered set and map, this question is super duper easy for you. And this is the most optimal solution also in this case. Now let's talk about how did I know that I have to use something like an unordered set and an unordered map. It is very important, which I always keep referring to in my videos, that whenever we talk about frequency, the first data structure that should always come into your mind is map, because it helps us store pair values, right? And therein we can store the frequency corresponding to a particular value. So I understand one thing, that for my approach, what I can do is I can have this data structure map. We'll come on to why did I say we will also be using a set. First, let's talk about why a map. So why a map? We will be using map because we are storing and we are going to work with the frequency, and map stores pair values. It helps us to know the frequency corresponding to the value of each number in the given array. So what will map do is, map will say, okay, let's quickly iterate over the array. I'm still considering this example here. So my map will say, let's create this mapping, right? And in my mapping, I'll have the number and I'll have the frequency. That means the number of occurrences of that number in my array. So similarly, I'll get a 1, right? So what I'll do is I'll say, okay, its frequency becomes 1 because it is first time appearing. Then I'll say 2 and I'll say it is not present in the map. So add it into the map. I'll go to the next number. I get again a 2. We'll simply increment its frequency. Now I'll move forward. I get a 1. We'll increment 1's frequency. We move forward. I again get a 1. We'll increment the frequency to 3. Now I get a 3, which is not present in my map. So I'll add a new instance. And eventually I have something like this, which is the number and the number of times it is occurring in the array. Now, according to the question, we have almost solved the half part of the question till this point. But what is the main goal? How can I return true or false? I can do that on the basis of uniqueness of number of occurrences, right? Or we can say instead of number of occurrences, we can say uniqueness of frequency of a number. So what I need to do is now I need to work with this section of my map. So for example, I was running a loop that is IT, right? That was running using an iterator, auto iterator IT, right? So here I'll be working with IT dot second, which corresponds to the frequency, which is the number of occurrences, right? So let's talk about why the unordered set. So guys, whenever we talk about uniqueness, we know that we have a set data structure which stores only unique elements. That means if I have multiple elements coming, then it will only store one instance of it, and we can easily find that if we have multiple instances or not, right? So set corresponds to unique storage. Hence, what I can do is I can further iterate over this section of my map, put it into a set. And at any point of time, if I feel that this element, this particular element, which is a number, is already present in the set, in that case, present in the set, then in that case, I will say that it means it is not unique. So it will mean not unique, and you can simply return a false. And else, if you have iterated over all the elements here and still you did not get a false, then you can return a true. So this is the approach. Now let's quickly have a dry run for the same. Okay, so let's assume this is the example. Now we are going to dry run this example. So first thing that we know is we are using something like an unordered map, which is having the int template. And basically in this, I'll be storing a mapping of the number and the frequency. Frequency is the number of occurrences. So I have this map here, right? I have this number and frequency mapping. My iterator begins from the 0th index. Let me quickly put in the indexes here so that it is easier. So I'm on the 0th index of the array ARR. So here I'll get a -3. I'll check if it is present in my map. It will say no, it is not. So I'll simply add this and I'll make its frequency 1. I'll move forward. I again get a element which is not already present in my map. I'll create a mapping 0, 1. Then I go to the next, I get 1. It is not present. Put it into the map. Then I go to the next index, I get a -3. -3 is already present in my map. So I'll simply increment the frequency. I'll move forward, I get a 1. 1 is already present in my map, increment the frequency. Move forward, 1 is again present, increment the frequency. Move forward, 1 is again present in M, so we'll increment the frequency. Incrementing the iterator, we get -3 now on the 7th index. And I see that yes, it is present in my map. So increment the frequency. Now I get a 10. 10 is not present in my map. I'll add a new instance. Then I get a 0. 0 is already present. So now increment its frequency. So after this, my map is storing something like -3, 0, 1, 10, and their corresponding frequencies are 3, 2, 4, 1. Now what I'll do is I'll be using a set data structure, right? And I'll simply iterate over this section and I'll keep putting it into my set. At any point of time, if s dot find the iterator dot second is not equal to s dot end, right? In that case, I'll say simply return a false. Now, what does this statement mean? This statement here means that my set already has the element you are trying to put. So in that case, the condition trying to put. So in that case, the condition of uniqueness fails and we'll return a false, right? So now I have a set here. I'll begin from here. I'll get a 3, it's not present in my set, added into the set. I move forward, I get a 2, not present, added into the set. I get a 4, not present, added into the set. I get a 1, not present in the set, that means unique, added into the set. I exhaust this frequency and I feel that I've iterated over all the elements here and I have not returned false. That means that yes, it is true. I hope the dry run was clear. Now let's quickly code this up. So this is the problem. So let's follow the approach. I'll begin with creating a map, unordered map data structure, right? With a template of intent. What I'll do is I'll simply iterate over all the elements in my vector array and I'll add them into my map, right? So from here, I get a mapping through this code. I get the mapping of the number which is present in the array and the number of occurrences of that number in the array. After that, I'll create a set, right? And let's simply give it int template. Now what I'll do is I'll run a for loop in my map and I'll say if s dot find, that means if my set already has the frequency value that I want to add into my set, in that case return a false, else simply insert that value into my set. And for example, I have not returned the false and I've simply executed this whole for loop, then I'll come out and I'll return a true. I think we're good to go. Let's submit it. And it is working fine. So let's quickly discuss the time and the space complexity corresponding to this. Okay, so this is the code. First, let's talk about the time complexity corresponding to this code. Here, I see that I am iterating in a for loop and it is for the number of elements that my array has. So let us assume my array had n elements, right? So this loop is for O of n time complexity. Then as every element will have a certain frequency corresponding to it, at least one would be a frequency. So again, for this for loop, we are iterating for O of n time. So in total, my time complexity becomes O of n plus O of n, which is 2O of n, which is equivalent to O of n. Now let's talk about the space complexity. Talking about the space complexity, I say I'm using an unordered map here and I'm using a set here. And in each of them, I'll be storing the number of elements. So it is O of n plus O of n, again 2O of n, which is equals to O of n. Hence, the time complexity for this code is O of n and the space complexity for this code is O of n. There's one more thing I would like to discuss before ending this video. A lot of people have tried solving this using no map and set. So even you can do that, but if you do this, the time complexity comes out to be O n log n and the space complexity is O of n. How you can do this is, basically, we know that we are given a vector, right? Something like 1, 2, 1, 1, 3, 4, like 2, 1, right? I've been given a vector like this. And what I can do is, if I do not want to use something like a map or a set, first I will sort. The first step that I'll do is, I'll sort the vector. So after sorting the vector, I'll get this vector as something like 1, 1, 1, 1, 2, 2, and 3. Right? So 0, 1, 2, 3, 4, 5. So after sorting this vector, you can create a new vector, something like frequency, which will be correspondingly storing the frequency. So as I talked about that this vector would be storing the frequency. How you can do that is that you can assume that you were on the first index and initially whatever was here, you can keep it in the current number, something like this. My current number is 1 and my current frequency corresponding to it is 1. I'm beginning from 1. So I'll say that if these two indexes have the same number, it will say yes. I'll say, okay, increment the frequency. Else, what I can do is I can simply push this into my vector here and I can again reset all these elements. So after doing this, what I'll have is in my frequency vector, I'll have 4 and I'll have 2 and I'll have 1. This is something that I'll have in my frequency vector. After having this, the third step that you can do is you can sort the frequency vector. So after sorting the frequency vector, everything gets aligned, right? So for example, let us assume that even 3 was occurring twice. That means here also we had a 3. So if here also we had a 3, then we would have had a 2 here and a 2 here. So now you can simply run a loop, and if you find two indexes having the same value, you can return false. Else, if you have traveled the whole of the frequency vector after sorting it and you did not find any conflict, in that case you can return a true. So here, as we are using the sort function, the time complexity becomes n log n because we are sorting it, then we are traversing it O of n, right? Then we are again sorting it, then we are again traversing it, right? So talking about the major effect for the time complexity would be of n log n. And again, the space complexity, because you have to create a frequency vector, you cannot work without it. So it is O of n. Hence, the solution that I've proposed before and the one that we have coded is a better optimal solution than this one. Thank you so much for viewing the video till the end. Please like, share, and subscribe.